All right, I'm excited that we're starting lesson 37 and I'm combining it with lesson 39. We're going to be solving equations. We're finally getting into some real algebra, solving for x, solving for unknowns using algebraic techniques. I am really excited about starting lesson 37 and 39. We are finally getting into some real algebra where we will be using algebraic methods to solve equations. So let's go ahead and get into it right now. The first thing that I wanted to do with you is just review what an equation is. I've written a definition out here on the left-hand side just to remind you that an equation is a meaningful arrangement of numbers or numbers and variables that are connected by an equal sign. And you can see I actually have three different equations here. This first one just simply states that 5 plus 3 equals 8, which we know is a true statement. As long as both sides are equal to each other, it is true. The second is an example of a false equation. A false equation occurs anytime one of the sides is not equal to the other. So 10 minus 2, that's really 8. So we know they are not equal to each other. Typically, you're going to take a line and you're going to mark through the equal sign to show that it's not true. The last equation that we have down here is considered a conditional equation. X plus 3 equals 5. Conditional means that it depends upon what you plug in for x, whether or not this equation will be true. One of the things I want to remind you about equations is that they are all about balance. In algebra, we must keep the two sides of the equation balanced at all times. So if we ever do anything to the right-hand side, we must do the same exact thing to the left-hand side. And you're getting ready to see what I mean. Now we're going to talk about solutions. We talked about what a conditional equation was and how whether or not it was true was dependent upon what we put in for x. Well, we want to know what the solution is. What should we put in for x in order to make the equation true? So if we replace the variable in a conditional equation with a value that makes the equation true, then we have found a solution. And you can see out here to the side, I have an example. If x minus 6 equals 10, then x equals 16. We always will check to see if that turns out true. If I put 16 in for x, do I get 10? Yes. So therefore 16 is a solution to that equation. Up to this point, when you have solved equations, you have done it using the guess and check method. Basically, you've looked at the x and guessed, what do I think x is equal to, and then checked it to see if that was true. But now we're going to start using the algebraic method for solving. In order to solve for a variable algebraically, we will use the opposite operation. I want to give you some examples of what I mean. Operations include addition, subtraction, multiplication, and division. I've listed some opposites below. Some operations that we have would be addition and subtraction. And then if I have multiplication, division would be the opposite. Now it's time to solve for x. If I want to solve for x, then I need to isolate x. You'll hear me use this terminology quite often. To isolate a variable, whether it's x or m, just means that we want to get that variable all by itself. So in this equation below, we have x plus 5 equals 12. I need to get x all by itself to find out what x is equal to. To do this, I'm going to use the opposite operation. All right, we look at our equation, x plus 5 equals 12, and we ask ourselves, if I want to get x all by itself, what do I need to get rid of? I need to get rid of the 5. Then I ask myself, what's happening between the x and the 5? Well, currently they're being added. So what is the opposite operation? To subtract. So I do that. I'm going to subtract 5 on both sides. When I do that, the positive 5 minus 5 cancels out, leaving 0. So now I just have x on the left-hand side. On the right-hand side, I'll take 12 minus 5 and I get 7. The final step is to go back and check. If I put 7 in for x in the original equation, what do I get? Well, 7 plus 5 equals 12. So it is a solution. In this next example, the only difference is that the opposite operation will be addition. If we look at the equation x minus 7 and we ask ourselves what is happening, currently they're being subtracted. So to get rid of the 7 and get the x all by itself, I use the opposite operation. I will add 7 to both sides. Whatever I do to one side of the equation, I want to do exactly the same thing to the other side. Remember, it's all about balance. When I add negative 7 and positive 7 together, they cancel each other out, leaving 0. Now I have just the x equal to 13. The final step will be to check. If I put 13 in for x, I would have 13 minus 7 equal to 6. That's a true statement, so I have a solution. Now it's your turn. I want you to try this one. There's an m, but that's okay. It's still just a variable. Ask yourself what's happening between the m and the 3, and then I want you to do the opposite. Pause this video, write down your work, and then I'll tell you whether you got the right answer. Alright, you should have added 3 to both sides. When you did, then the 3's would cancel, leaving just the m equal to 11. Final step, go back and check. Is 11 minus 3 equal to 8? Yes. So 11 is the solution to our equation. Alright, I want to show you one more with a fraction. Fractions work exactly the same way as whole numbers. Again, all we're looking for is what is happening between that x and the 1/3. Currently, they're being added. I need to use the opposite operation to get rid of the 1/3. So, I'm going to subtract 1/3 on both sides. Now this time, I do have to get a common denominator so that I can find out what it's equal to. Currently, my denominators are 2 and 3, so I'm going to need to change them to 6. 1/2 will become 3/6, and 1/3 will become 2/6. I will subtract these, and I get 1/6. The final step will be to check. If I put 1/6 in for x, and I add that to 1/3, do I get 1/2? Again, I have to get a common denominator to check. So if I have 1/6 plus 2/6, I get 3/6. And is 3/6 equal to 1/2? Yes. So 1/6 is my solution. Okay, this is the last one. I want you to try it. You will have a fraction. I want you to use the opposite operation. Pause this video and try it by yourself, and then I'll tell you what the answer is. You should have subtracted 3/4 on both sides. In order to do this, you would have to get a common denominator. 3/4 minus 3/4 is 0, causing that side to go away. On the right-hand side, my common denominator will be 8. The top fraction is not going to change. It's still 7/8. 3/4 will become 6/8. When I subtract that, I get 1/8. So now it's time to check it. If I replace x with 1/8 and I add that to 3/4, do I get 7/8? Well, again, I have to get a common denominator. 1/8 can stay the same. but I'm going to change 3/4 into 6/8. When I add 1/8 and 6/8 together, I get 7/8. So 1/8 is a solution to my equation.